In today's video, we will learn how to graph a linear inequality. This is very similar to graphing lines. We're just adding an extra step at the end that helps us decide which way we're going to shade. So when we're graphing lines, the first thing we want to do is we want to choose the method or the form of the line that we can then graph. So in this first example, this form most closely follows y equals mx plus b. Okay, once we've chosen the form, we're going to identify and graph the key features. So in y equals mx plus b form, the key features for graphing are the slope and the y-intercept. In this particular line, my slope is 1 and my y-intercept is 4. So I'm going to plot a y-intercept first. I go up 1, 2, 3, 4, and then I'm going to follow my slope of 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. And this I want to make sure I continue all the way through the grid. For graphing inequalities, it is really important that you make sure that your line extends throughout the entire part. Because when you shade, you want to make sure that you're only shading solutions. And if your line doesn't extend, it might get a little bit crooked. And then you could end up shading answers that aren't actually solutions. Before I connect the points, okay, I need to decide whether or not my inequality should be a solid line or a dotted line. So if you remember in the last video, a solid line is when you want to include the points that are on the line, and a dotted line is what we use when we want to not include the points that are on the line. Or I should put don't include, not include. Okay, so I'm going to look at my inequality symbol. This inequality symbol is underlined. It says less than or equal to. When I have the symbol underlined and I want to include the points that are equal to the value, then I want to make sure that I use a solid line. So I'm going to use a solid line to connect these points. So we'll do that, connect them all the way through, okay? And then that helps me make sure that they're straight if I make sure that the points are all the way through. The last step after we've drawn the line is we have to decide where to shade and shade appropriately. I like to do this, I find it easiest to decide where to shade in slope-intercept form, I like to compare the y-intercept with the inequality symbol. So in slope-intercept form, this is saying I want the y values to be less than 4. So where are the y values? If I think in comparison to the y value of 4, where are the y values less than 4? And that would be below the line. So for this problem, I'm going to shade below the line. Okay? What I really did there was I substituted in the point 0, 0. And I asked myself what happened with I substituted in 0 for x, and I asked myself how to compare the y values. Okay, another way that you can do this is you can substitute in the point 0, 0, or any point not on the line. So you can substitute in a point that's not on the line. So for me, this was 0, 0, and I'm going to highlight where 0, 0 is. Okay, this is before I decide where to shade, right? So if I put 0, 0 into my inequality, that would be, I'm putting that into y is less than or equal to x plus 4. So I'm asking myself, is 0 less than or equal to 0 plus 4? Yes, 0 is less than 4. So therefore, this blue point is a solution, and that lets me know that I want to shade it. So that helps me understand that I'm going to shade the lower half of that line. Let's do a problem where it's not already in standard form, because this can get a little bit trickier. In slope-intercept form. In this next example, we have a problem that's in standard form. So there's two options for graphing this. Okay, option number 1, you can convert this into slope-intercept form. And option number 2, you can graph using standard form. A lot of students like to convert into slope-intercept form because they feel the most comfortable graphing in slope-intercept form. I prefer graphing in standard form. because it's less work. It does not matter which way you choose to do this. It's totally up to you. I'm going to show both ways so we can see that we get the same answer. So first I'm going to go ahead and graph this in standard form. In standard form, I would identify the x-intercept and I would identify the y-intercept. To find the x-intercept, I want to substitute in 0 for y. So the x-intercept is going to be the solution when I get negative 10x plus 5 times 0 being equal to 5. Oops, I'm running out of room here. So negative 10x plus 5 times 0 has to equal 5. Now, for the sake of this problem, I'm using an equal sign because I'm solving for the x-intercept. So I'm actually changing this from an inequality to just an equal sign. So the x-intercept ends up being negative 10x equals 5. So the x-intercept is negative 1/2. I'm going to go ahead and plot an x-intercept between 0 and negative 1 there. The y-intercept I can get by substituting in 0 for y, or for x. So that would be negative 10 times 0 plus 5y has to be less than 5, or equal to 5, let's do. So that means that 5y must equal 5. So that means that if I divide both sides by 5, the y-intercept is 1. So I would plot a y-intercept of 1. And then what I'm going to do is I'm going to think about what the rate of change is so I can extend these 2 points throughout the entire graph. So my first point is a half unit away, and then I go up 1 and over a half. So I'm going to do that continuously through the graph. I go up 1 and over a half, up 1 and over a half, up 1 and over a half. And I'm going to just keep doing that pattern until I get all the way through the graph. I can do that the opposite direction also. Down 1 over a half, down 1 over a half, down 1 over a half, until I get all the way through. I have to decide how I'm going to connect the points. Will I connect them with a dotted line or a solid line? Okay, again, solid line means you want to include the points. Dotted line means you don't. This symbol says strictly less than. So I don't want to include the points that are on the line because I want to be strictly less than. So what I'm going to do is I'm going to do a dotted line. I'll just connect every other dot here so that I can tell this is a dotted line. And now I have a dotted line. And last but not least, I have to decide where to shade. So I'm going to pick a point that's clearly not on the line. So this point right here is 2, 0. So I picked 2, 0. I'm going to substitute 2, 0 into the inequality 10x, negative 10x plus 5y is less than 5. So negative 10 times instead of x I write 2, plus 5 times instead of y I write 0. And the question is negative 20 less than 5? It is, so that means I need to shade that blue point and every other point that's on the same side of the line. If you want to convert, oops, that didn't shade. If you want to convert this into slope-intercept form, that's also acceptable. So converting this into slope-intercept form, you have negative 10x plus 5y is less than 5. To get the y by itself, we would first add the 10x to both sides. And then we would get 5y is less than 5 plus 10x. And then we would divide everything by 5. And so you end up with y is less than 1 plus 2x. We have a y-intercept of 1 and a slope of 2. So we can plot our y-intercept of 1. If I zoom in on this graph, that y-intercept is the same, and the slope is 2. So from the y-intercept, we go up 2 over 1. We land in the exact same spot that we did for the first line. Up 2 over 1, up 2 over 1. And we can see that this would end up being the exact same graph. Then we would just want to verify that our symbol is correct. So this is saying I want the y value to be less than, I just compare to the y-intercept, so I want the y values to be less than 1. Which way are the y values less than 1? Below the line. So I would shade below the line. So either way, you get the same answer. I hope that helps as you're graphing your inequalities.